All right, guys, we are going to consider this is our question paper that we wrote in our June 2024 exam, which is our paper 2 for mathematics. So I want us to go through this question paper, guys. Let us understand the questions, how they are given, read your instructions, as I always say. So the major part in this is that you can use your calculators this time, and also you're supposed to answer all the questions that are in section A and any 4 questions from your section B, which is very, very important to understand. And also the degree of accuracy, whenever it is not specified, give your answers to 3 significant figures, and answers in degrees should be given correct to 1 decimal place. Okay, so this is what we got. That's the major part of our instruction, guys. Do not answer the questions without reading the instructions. So our section A, as we know, that is 52 marks. Answer all questions in this section. All right, this question, which is our question number 1, guys, I want you to understand. Do not just read and rush to answer the question. No, do not just read and rush to answer the question. They are saying here on number 1A, I want us to be together. Mr. Moyo's basic monthly salary, that is the basic monthly salary. So yes, a basic monthly salary that is given of $205. Take note, he receives a commission, which is true, of 2% for any sales above. This is the key statement here. So we are not reading to understand the questions. We're just, okay, there's a commission. No, it's not about a commission. What is it that you're given on that commission here? Above. Above. What does it mean? Above $500. Anything above $500. That is, any sales above this, anything that is above, that is when he is starting to get a... Okay, let's have this thing here. If you are given a commission, we do understand that a commission is a percentage that you do get after you have worked for a certain amount that maybe you're selling something, then you're given a certain percentage. So that percentage, it is a condition, it is given as a condition. They can say you're given 2% of the sales that you make, or 2% of the sales made. If it is 2% of the sales made, 2% of the sales made means 2% of whatever that you have. Meaning if it is this one, you take that as it is, 2% of that. But this is not the case here. No, it's different. Pantuanem siyano up. Not in this one way. Zviri pamusoro, zvinenge zvava pamusoro pa 500 ndo patinotangira kuwana commission. Any sales above. Meaning to say, if he is at $500, he's not having that commission. He's not having that. There's nothing there on 500. So if he is, let's say he made sales of $600. This is the sales. He made $600. Meaning to say, of the $500 that he's having, this one, it was of waste. It's just like a waste. Hapana chatinacho pa 500 ipapo kwete. Zvinenge zvava pamusoro pa 500 ndo zvatiri kuda. Zvava pamusoro pa 500. What is above that? So from this, we are going to subtract 600 minus 500. We start from there. Apa ndo patinotangira commission. Ndo patinotanga takukupa commission 2%. Kwete pa 600 yawashanda. Kwete nokuti wava nezviri pamusoro pa 5, saka tikupa 2% izvi. No, kwete. Zvakatosiyana. It was just a simple English that was there. If you do not read that and understand, you make an error to use this part of a 2% of everything. No, that is not the case. It's not 2% of the whole part of that way, what you're given. The 500 is useless, this one. It's like, no, there's nothing. It's like you haven't started working. So meaning to say, the 2% is taken from what is above. So in this case, we are given that. Calculate his gross salary for the month, which means the total of everything for the month. If his sales were, he made these sales. This is the sales that he made. But the commission is 2%, 2 over 100 of what is above. So it's going to be 1,550 minus the 500 above this. We have to remove that. At 1,550, we are talking about the 2% of everything, not 2% of what is above. We need 2% of any sales above zviri pamusoro pa 500. Ndo zvatinocalculata 2% yazvo. All right, I just hope you understand me on this part. So that was going to be 1,550 minus 500, which is 1,050. That is 2% of 1,050. This paper, the calculators are there to be used. Ndo basa recalculator. Ndosaka tiri kuudzwa kuti calculators may be used in this paper. We can use the calculators, okay? The mathematical table. So on this multiplication, just use the calculator direct. Do basa calculator. That is the use of the calculator. Multiply this direct on your calculator. This was going to give you a 21. That is the 2% of this is $21. This is the commission he obtained. This is the commission obtained. So meaning to say we are having a commission here of 2%. That's a commission of the 2% above that, which is going to be $21. So at the end, the sum of these two gives us the gross salary. We're now talking about the gross salary, which is 205 plus 21. And that was going to give us $226. That is $226. So I want you to be careful. So the question is, guys, you come out of the exam with so much excitement. This one is, no, understand the questions. And nowadays, we also have problem of us learners having same mistakes as our teachers also. You come out of the exam, you ask your teacher, how do you answer this one? The teacher is working the same way that you were answering. Then you think you are right. No. Understand, the same internet that you are using to watch this video, use it to search these. You can type these questions like this, guys. You can type it like this, exactly as it is like this. You can type it. The same data that you are using to watch this video, use it to type. Also, search these things. Search as a student. A student, you're not supposed to get from everything, What are prime numbers? The same data that you are using to go and watch a video, use it on a normal browser. What are prime numbers? You get the answer. You don't need to wait for someone to come and explain what are prime numbers. So let's revise also. Let's revise, understand the concept so that as a student, you're also supposed to ask a question. How are you doing like this? Why? You must have a reason also. Put there. Okay, anyways, let's see. Item 2. In a certain month, the following deductions were made. Okay, this is the guy who is working. Then they remove the pension, medical aid, the income tax. Calculate his net salary. The net salary is after deductions. But they are saying for the month, he made sales of this 1,500 for this month. If you check, this is the month here, the month when he made the sales of 1,550. His gross salary was 226, the one that we have there, the one that we calculated. So meaning to say on this item 2, the first thing that we are going to take is the gross salary that we obtained above. We know that when we calculated this, it was 226, meaning to say if this is wrong, also this is going to be wrong. Also this part is going to be wrong. Imagine 6 marks gone for like that. Guys, let's revise, okay? So this is it. Calculate his net salary. So the net salary now is that you're going to remove these deductions. So if you add these deductions together, like I said, guys, this is paper 2. That's the use of a calculator. So if you're going to add this, you're going to obtain 10,05 as your deductions. Together, this total, if you add everything. So from there, to obtain the net salary, you're going to subtract. That is, the net salary is going to be the gross salary, which is everything before deductions, minus the deductions of 10,05. That's the use of your calculator. Again, use your calculator. You're going to obtain that is $215.95. Okay, so be careful. The deductions, these are something that you are removing from the money that you're having. You remove that. So these are deductions. All right, B, we are given the sum of the interior angles of a polygon is double the sum of the exterior angles is double the sum of the exterior angles. All right, we do understand that for any polygon, these exterior angles, they add up to 360, the sum. You're talking about a shape with 4 sides, a shape with 5 sides, 7, 8. The exterior, the sum, if you add, they add up to 360 degrees. But the question is, the interior angles of a polygon is double the sum of the, it is double, meaning to say the sum of the interior angles in terms of the interior angles, the sum is double, which is 2 times 360 degrees. And that was going to be 720 degrees. That is the only, this statement on its own, that is what it means. This statement, before you read this question, that is the statement on its own. So the question is now, find the number of sides of the polygon, the number of sides. Knowing the interior angles can help us to calculate the number of sides, because this, we are not told that it's a regular polygon, it's just a polygon. So it is best to work with the interior angles. Why? Because we know that the sum of interior angles is n minus 2 times 180. So n minus 2, which is the sum of interior angles, is equal to the sum that we are given of 720 degrees. All right, so let's divide 180 degrees into 720 degrees. So this into this, it was going to be given 4 times in this case. So that is going to be 4. So to find n, transpose the 2 so that it becomes positive. It was a negative, so it will be a positive 2. So n is 4 plus 2, which is 6. That means this polygon has got 6 sides. All right. Let's consider another question, which is 2. That is question number 2a. Solve the equation. So there we are given, that is 6x minus 2 is equal to 2x plus 8. So you can solve this by transposing the power of x to where x is, the minus 2 to this, that is collecting of like terms. So 2x this side will be a negative. So it's going to be 6x minus 2x is equal to 8. Already there's a negative 2. On this side, transpose it, it's going to be a positive 2. So 6 minus 2, that will be 4x is equal to 10. So in this case, we can divide by 4. That means our x was going to be, you divide here by 2. Okay, this is your calculator, guys. That's the purpose of your calculator here. That was going to be 2.5. So that is the value of x 2.5, or it can be 2.5. So also as a decimal, you can write your answer as 2.5. All right, so that was our equation. Then 2b, you're asked to factorize 5h squared minus 20k squared. All right, what is it that we are having here? Let's see, that is 5h squared minus 20k squared. So if you take a closer look, this is not a difference of 2 squares, because 5 is not a perfect square. 20 is not a perfect square. But if you are to factor out 5, because 5 is the highest common factor between these two numbers, 5 and 20. So you divide 5 and 5, that will give us h squared 20 and 5, that's going to be negative 4k squared. What is remaining inside of the bracket is a difference of two squares. So there we can use the difference of two squares concept. Remember, that is determine the square root of this, square root of everything. This is a perfect square, a perfect square, a perfect square. So you have to consider every term. Square root of h squared, which is h, the square root of 4, which is 2. So you're going to have 2k, the square root of k squared. So remember, one of the bracket will subtract, another bracket will add, or one of the bracket adds, another bracket will subtract. It's up to you. That's difference of two squares later on. So that is it, guys. For 3 marks, you are going to have the full marks. Then on item 2, you're given again to factorize, and this is 2mp minus m minus 6np plus 3n. Okay. Remember, when given 4 terms, you think of the grouping 1, 2, 3, 4 terms. So the question is, if I group these terms into 2 like this, am I having a common term? Am I also having a common term here? So you can see that for the first 2 terms, m is common. So you can factor out also on this part, n is common. All right. So let's factor out m for the first 2 terms. If you factor out m, that was going to be 2p, divide m and m cancels, minus m and m cancels, that was going to be a negative 1. So meaning to say we are having 2p minus 1. But remember, this is supposed to be the same as what you are going to obtain from these 2 terms remaining. So what will make this to be the same as this one? Okay, it's a positive, this part. There is a negative. So I'm supposed to factor out a negative so that this will be positive. Let's consider the numbers 6 and 3. 3 is the highest common factor. The terms, there's n, there's n. So you're going to factor out minus 3n. You divide this term to this term. So that will be positive 2p. The n and n cancels. 3 and 3 cancels. That will be minus 1. N and n cancels also. So you see that this bracket and this bracket are common. So you're going to factor that common bracket, the 2p minus 1. We remain with what? In this case, that will be m. On this part, that is minus 3n. So in this case, we are having 2 brackets at the end. That is our simplification. We have factorized this. All right. On part C, you were given to simplify or to express this as a single fraction in its simplest form. Not just as a single fraction, but it must be in simplest form. All right, so that's our part C. We are given 3 into the bracket of x minus y minus 2 into, 2 into 2 over x plus y, 3 over x minus, that's what you're given there. So you can consider your LCM. It is like that. Or just interchange. This multiplies this, this multiplies this, having the same LCM. So that's easier like that, guys. I explain this, that you can also just have it like this. If you are someone who is having a confusion, this term is different from this one. So you take this one to be multiplied to this. You take this one to be multiplied to this. That is the concept. Or you simply divide. If you divide this to this term, what will happen? This bracket and this bracket will cancel. You remain with x plus y. But you do not cancel. You assume as if you are canceling this, but you do not cancel. The same thing, the x plus y, the x plus y cancel. You remain with x minus. Again, you assume as if, but you do not cancel these brackets. All right, so that will be this way. Let us expand brackets, collect like terms. 3 times x, that will be 3x. 3 multiplies y, in this case, that will be 3. Y minus 2 times x, minus 2x, minus 2 and a minus, that is a positive 2y, everything over the 2 brackets that you are given, which is x minus y into the bracket of x plus y. All right, let's collect our terms. They've got like terms in this case, the x part and the x part, 3x and 2x. All right, these are the like terms that you're considering here, this part and this part. So you can combine those terms. That is 3 minus 2, that's 1x. But remember, 1x is same as x. The same part with the part of y here, the y and the 3 and the 2, that will give us 5. So that will be 5y in this case over the two brackets, x minus y into the bracket of x plus y. Just like that. And do not cancel anything in this case, like x and x. No, there's that is canceling. And unless if the two brackets are the same, like what you, the numerator and the denominator are the same, you can cancel. Not like this. There's nothing that, so do not be tempted to cancel x and x. No, it's impossible. It's impossible. So that was our fraction in simplest form. There's nothing that we can do. So that is the simplest form that you can have. All right. On question number 3, because this is done question 2, let's move on to question 3. We are given on question 3A, Mr. Dube had an appointment with a doctor at 1400 hours. That is the time of the appointment. Supposed to meet at 1400 hours. Mr. Dube arrived 14 minutes earlier before this 14 minutes earlier. We do not want even to know about that time, but we know that he arrived 14 minutes earlier. This one, it's early. And the doctor was 15 minutes late. We do not even want to know what time was it when he's coming. No. The difference is that they are in between the 2 p.m., which is the 1400 hours. This one is 14 minutes earlier. This one is 15 minutes late. So the question is, how long Mr. Dube had to wait before the doctor arrived? Remember, he was supposed to wait for 14 minutes to open. The 14 minutes elapsed. Wait for 15 minutes. So he's waiting for this 14 and the 15. The 14 he's waiting is for this 2 p.m., which is the 1400 hours. The 15 minutes is for the doctor. He's late on his own time. This is it. So you're supposed to add the 2. So that is 14 plus 15, which is 29 minutes. So he was supposed to wait for 29 minutes. The 14 minutes, it's on his own. He was the one who was early. But he's supposed to cover that 14 minutes and also the 15 minutes of the doctor. That is the concept there. All right, so that was going to be 29 at the end. Then B, find the difference between 4 weeks, 3 days, and 2 weeks, 5 days. As you can see, 4 weeks is bigger than this. So you're going to subtract 2 from 4. So that is 4 weeks. In this case, we're going to have something like this, 4 weeks, 3 days. Then there we have got 2 weeks, 5 days. All right, let's subtract 3 minus 5. That is impossible. So in terms of time, you borrow a certain amount, which is equivalent to the days that you want in this case. Like, what is equivalent to a week? But in terms of the days, we know that in terms of the days, 7 days is equivalent to a week. If it was time in terms of seconds and maybe minutes, you are given something that is to relate minutes and seconds. You relate from there. A minute in seconds. So in this case, a week in days, 7 days. So meaning to say, if I borrow a week, if I remove a week here, I'm remaining with 3 weeks. But the week that I have taken, it is equivalent to our main days because these are days. This side, these are days. So this is 7 days. So you add the 7 here. That will be 10 days. So let's subtract 10 minus 5. Now it's possible. That will be 5 days. You do the same thing on the weeks. 3 minus 2, that is 1. So you've got 1 week 5 days in this case. So we're talking about 1 week, 5 days. That is the difference that we are given in terms of weeks and days. All right. Then C, Mary cycles to and from. These are two things to be considered, to and from a school 5 times. So he's going to and from 5 times. Okay. The school is 5 kilometers away to the nearest kilometer. Remember, to the nearest kilometer, we are given that condition where we can have the lower and the upper limit, which is the least and the maximum value that we can expect to have. So the question is to calculate the smallest possible distance, meaning to say from the 5 kilometers that we are given, let's work from there. From the 5 kilometers, because it is the one that is given to the nearest kilometer. The least possible distance from this 5 kilometer is going to be what? That will be 4,5 kilometers. Remember, for the least, you subtract 0,5. For the upper boundary or for the maximum, you add 0,4. You add 0,4 to the nearest whole number. You subtract 0,5. For the least, you add 0,4. That is, if you are working with the nearest whole number, because if you're given to the nearest kilometer, that means to the nearest, the unit that is given to the nearest whole number. So you consider 4,5 as the least possible distance that we are given only from this school. But in this case, we need the smallest possible distance she cycles. We are given that Mary cycles to and from. To and from. Times. So to and from. So let's consider this. 4,5 times. How many times? This is 5 times, which is taken to and from. So this is the number of times taken, that is, she cycles. Then this is to represent to and from. There are 2 things to be considered, going and also coming back. So you're supposed to multiply by 2 at the end, meaning to say that will be 45 kilometers. So you work the least possible value, you use it to the condition that you are given. All right. B, you are given the population of a town is, town A is this, and that of town B is this. So the question is, from these 2 populations that we are given, item 1, calculate the difference between the populations A and B. Give your answer in standard form. Your answer is supposed to be in standard form. So on the subtraction, you can either work them as they are in standard form, or you can convert these numbers to ordinary form. Times 10 to the power of 7 simply means we've got 4,52. We are moving how many commas? 7 to the right. 1, 2, 3, 4, 5, 6, 7. In place of these groups, we're going to have zeros. In place of these, zeros, zeros, like that. So meaning to say, this is simply 4, 5, let's just say 3 zeros, 5, so it's going to be 45,200,000. And the other one, you do the same thing, 8,7, 6 commas, 1, 2, 3, 4, 5, 6. In place of these groups, that's 0, 0, 0, 0, like that. So this is simply 8, that's going to be 8,700,000. So looking into these numbers, we can see that this one is smaller than this. Here is smaller than this. Yes, you can compare them in standard form by that, which is fine. So we can subtract town A minus town B. So in this case, we are going to subtract, that is 8,700,000. I said this, the use of your, that is the use of your calculator, paper 2. Use your calculator. That was going to be 3 million. That was gonna be zeros. They're gonna have 1, 2, 3, and this was gonna be 0. Guys, sorry for that. Sorry for that. I need the difference there. So you're gonna have a 0 here. A 5 is here. So that is this one. It's gonna be 5. Then we give this 9. That's 1, 1 here. All right, so 15 minus 9, which was gonna be 6, and that is 3. So meaning to say I've got 36,500,000. And this can be written in standard form 1, 2, 3, 4, 5, 6, 7. Remember, our answer is supposed to be between 1 and 10. 3,65 times 10 to the power of 7. It is easier for you to add or subtract in ordinary form. I'm not saying you cannot do that in standard form. You can do that if you want by factorization, which is fine, or you can just convert your numbers to ordinary form. Given on item 2, you're given 40% of the population of town B are adults. 40%. Calculate the number of adults in town B. The 40% represents the adults. So that is the one that you need. And give the answer in ordinary form, meaning to say you're supposed to work this in ordinary form. Remember town B, this was the population for town B, and we are given that 40% of these are adults. So it simply means 40 over 100 times the number of people in town B, but being in ordinary form like this. So like I said, guys, paper 2, that's your calculator. That is where you're going to use your calculator in the simplification. So this was going to give us 3,480,000. That is our number in ordinary form. You're given to have this in ordinary form, meaning to say you're supposed to keep your answers, your final answer as it is. Do not convert anything from that part, all right? So that was our part of our question. So guys, I just want to remove this other part. You know, these softwares, guys, they just have a tendency of misbehaving sometimes. So let's just see. Okay, so that's it. 2 marks for that. Simplify this. Okay, we are not given to, that is number 4. You're not given like as a fraction or as a decimal. Just simplify. So what you can do is simply add 0.35 plus 0.25. Again, this does not affect on your calculator. Add these two. That will be 0.6. 0.3 times 0, that's your calculator. That's the use of that calculator. 0.012. Then you divide. For 2 marks, all this part it's a mark. And the answer there's a mark, which was going to be 0.072. Or if you want to have it as a fraction, 0.6 over 0.012. That's going to be, you multiply these two. If you want to have it as a fraction, remember I said you keep the decimals. I mean decimals that you're given. You focus, on the decimals that you're given on the denominator. There are 3 digits after the comma. 1, 2, 3. So that means you're going to multiply by 1,000 over 1,000. You focus with the denominator to be a whole number. 0.6 times 1,000, just move 3 commas to the right. 1, 2, 3. That will be 600. So this is 600 over, that will be, in this case, if you move this, that will be 1, 2, 3. Meaning to say, we are going to remain with a 12. That is what we are given in that case. So you consider what you are given in the denominator and also what you're given in the numerator. Sorry for that. This is 1,000. That is 0.12 here. All right. Sorry for that. Just gonna put it this way. This one, I worked it the other way, okay? So this one is the one that I worked out the other way. This one, it was supposed to be a 50, okay? So that will be, in this case, a 12, all right? So that will be a 12. So this one into this, that is a 5, a 0 there. All right, so the way that I had it before, it was like a vice versa. When I was working this one, I worked it with a vice versa, but that is 0.6. You must use your calculator properly, add properly the numbers that you are given. You can use your calculators if you you have got a problem with your decimals. Whenever you've got a problem with your decimals, this is paper 2, like I said. And also learn to verify your answers. Learn to verify, because this is paper 2. You can use your calculator direct to verify what you are given at the end. Like what I'm trying to say, use this whole fraction as it is here. This one as it is. You just use your calculator as it is to verify if you are obtaining the same answer that you had. So I want you to correct that part. So this will be a 50, which is a 50 here. All right. So for 2 marks, that is actually enough for you to for 2 marks, guys. Okay. Just use your calculator, like I said, if you've got any problem on that part. On item B, we are given to evaluate this, giving the answer in base of 2. So this is up to you. Either you're going to have the first number in the base of 2, or you convert both numbers to the base of 10. It's up to you. All right, so this is B, 4, 3, base 5, plus that's 1, 0, 0, 1 in the base of 2. All right, so let's consider, as for me, I'm just going to work with this one in the base of 5. In the base of 2, I mean, remember, we are asked to give our answers in base 2. So already this other number is in base 2. So you can just leave this as it is. So let's focus with this, 4, 3, base 5. How do I convert a number to base 2? You can convert this to base 10, which is the easier part that most of us do understand, by raising to the powers of the base. 4 times 5 to the power of 1 plus 3 is going to multiply 5 to the power of 0. 5 times 4, which is 20. That's 1 times 3, which is 3. So this was going to be 23. Let's convert this to the base of 2. Remember, you're supposed to divide by 2, noting all the remainders. All right. So that's 2 into 23 into 22. That is actually 11, remainder 1. 2 into 11, that is going to be 5, remainder 1. 2 into 5, that will be 2 into 4, remainder 1. 2 into 2, that is a 1. So this one, it's a 1. And we've got a remainder of a 0. In this case, 2 into 1, that is a 0 and a remainder of 1. So this and the base of 2, remember, we're going to take our answer from the bottom upwards, going up. All right, so let's consider our answer from the bottom going up. That was going to be 1. Then we've got a 0 in this case, a 1, 1, 1 in the base of 2, plus 1, 0, 0, 1 in the base of 2. So that's it. Let's add our numbers in the base of 2. So that's, we're going to have 1, start with these numbers going this side. That's a 0, a 1, okay, in the base of 2. Then we can add 1 plus 1, that's a 2. So remember, you cannot write 2 in the base of 2. You cannot write 2 in the base of 2. You divide by the base. So the 2 there is the base. So 2 into 2, that's 1. Remainder 0, the remainder. On your answer, this one, we are going to give it to the next term. 1 plus 1, that's a 2 again. 1 remainder 0, it's a repetition. We give this one to the next term. Again, 1 remainder, that's again. We do the same thing here. 0, we give the same. That's a 0. We give a 1, which will add. What is going to add here? That's a 0. There's nothing. So that's 1 plus 0, which is 1 in the base of 2. All right. So there, they just wanted you guys to go through all this. Like I said, you could have converted these numbers to the base of 10. You add them in base of 10, then you convert to base 2. It's up to you. That one is up to you. B, a rectangular garden. It measures 15 by 12 centimeters to the nearest meter. These are already meters. And to the nearest meter, like I said, we are going to talk about the 0.5. and the 0,4 for the least and for the maximum. So we're given to calculate the least possible area. So the least, we're going to remove 0,5 from 15. We subtract 0,5. We subtract 0,5. So meaning to say our area, in this case, because we need the area, is going to be what? This 15 minus 0,5 was going to give us 14,5 times 12 minus 0,5, which was going to be 11,5. So our area at the end is the product of these two, which is 166,75 square meters. Also confirm with your calculator. If we are together, you know, this, you just make a simple mistake when using your calculator, being tired, this and that. So let's also confirm on our calculators if we are together on that part. B, we're given A is equal to 3,12 times 10 to the power of minus 3. That is the value of A, which is same as 3, because there we're going to talk of addition. You can convert to ordinary form if you want. That is moving 3 commas to the left. There's a negative. So let's move 1, 2, 3. Inside of this group, we're going to put a 0. That's a 0 here, a 0 here. So meaning say A will be equal to 0,00312 in ordinary form. That is what, if you want to write it in ordinary form, like I said, you can also do addition in standard form as it is. 4,5, 4 commas to the left. So that will be 1, 2, 3, 4. Less of this, we're going to put 0, 0 like that. So the comma is here. So means our B is 0,00045. This is what we have. So the question was to find the sum of these two, A plus B, the first one. So A plus B is simply adding these two. That is 0,00312 plus 0,00045. Do not worry about the order because that's paper to add using your calculator. That was going to be 0,00357. Then you can convert this to standard form. That is 1, 2, 3. So this number was going to be 3,57 times 10 to the exponent of -3. Remember, you are using a 0 digit. So at the end, we are supposed to have a negative exponent. So that was going to be a -3 in that case. So let's revise as much as we can. Item 2, A times B, that is the product, 3,12 times 10 to the exponent of -3 times 4,5 times 10 to the exponent of -4. This is our A, and that is our B. So multiplication, multiply the numbers separately. 3,12 times 4,5. This was going to give you 14,04. Like I said, let's also confirm in our multiplication as well. So that was going to be 14,05. You're multiplying the bases which are the same. The base of 10, the base of 10. You add exponents, -3 plus a -4. So that was going to be a minus at the end. -3 minus 4, that is -7. This is not in standard form because that is 14, above 10. Bigger than that. It's bigger than what we're supposed to have within the interval. Remember I said if you're to write this, A times 10 to the exponent of n, A is supposed to be greater than or equal to 1, but less than 10. This number is out of the interval. Convert this back to standard form. That is going to be 1,404 times 10 to the exponent of 1, because that's a significant digit that you're working with. You're working with a significant, so it remains as a positive, times 10 to the exponent of -7. If you're multiplying, you add the exponent because the bases are the same, just like this part. So it's going to be 1 plus -7. 1 plus -7 simply means 1 minus 7, which is -6. So that was going to be to the exponent of -6 at the end. You consider the bases which are the same, you're multiplying, you add the exponents. So that was it, guys, in standard form. On question number 5, which is construction, you are given answer the following under the whole of this question on a sheet of plain paper. Use ruler and compasses only for all constructions. Show all construction lines and arcs. On a single diagram, construct this on a single diagram you're given. So we have got a sketch that we need to consider. It's a quadrilateral A, B, C, D, where AB is parallel to BC. There's an angle B90 and angle C. Okay, this is ABCD, but B is 90 degrees. Then C is 60 degrees. Remember, we just need a sketch. So just something like this. And we are told that these two lines, they are parallel. So it's just going to be like this. This is a sketch, guys, all right? Just going to have my sketch here. So we are given here that this quadrilateral is referred to as ABCD. B is having 90 degrees. So let's say this is A, B, C is at 60 degrees. So this can make sense, our 60, 60. Our C, 60 degrees. A, B, C, up to D, okay? AB is parallel to BC. AD is parallel to BC. These two sides, they are parallel. So if they are parallel, there is no way this angle must be 90 degrees. Remember, from our co-interior angles add up to 180. So 180 minus 90 is 90. 180 minus 60, this angle must be 120 degrees. This is the concept that you just understand about your parallel lines. So you're given BC is 10 centimeters from B to C, 10 centimeters. And also AB, we are given this as 8 centimeters. So they are asked to construct this on a single diagram, 5 marks for all the constructions to be made. All right, I'm just going to hope this will work, guys, here where we are. Let me just try have it this side. All right, I'm just going to try reduce again because all these sketches, all these constructions, once affected, guys, it's not going to be clear. So this is what you're going to need. You're going to need your compass. For the constructions, we need this and our ruler. Like the instruction, we are given use ruler and compasses only in these constructions that you are going to have. So let's just say we have got our line BC as our reference line, because everything can take it from the line, BC that you're given there. So I have got my line, which is the reference line, where I'm going to construct an angle of 90 degrees at B. So let's say I want my point B here. It's up to you. This is your reference point, the point that you are starting with. So you can have it here. All right, that's where you want your B to be situated. It's up to you, like I said. But at that point, that is where you're going to construct 90 degrees. Remember how you construct 90? Just open a certain distance, construct this side, also do the same on this side. With these 2 points that you constructed, you're going to open more than half of the line. This is at half. You open more than half of the line, construct an arc on top, okay, which is enough. You also move to this side. You construct an arc on top also, so that these 2 arcs, they do meet without changing the distance that you are using, which is more than half of the line. Without changing that, you can construct 90 degrees. Already there's a reference point here. So there's no need for us to have these arcs down here, because already we have got a reference point. I'm not saying it's wrong to have that. No, I'm not saying it's wrong. You can have that. You can have those points down there. But if you've got a reference point and that point that you're having here, it is enough. You can join up to that point just a little bit, to that point like that. All right, so this is our 90 degrees from this point B. We have got 90 degrees. And we are given that from B to A, going up is a 90 degrees because these 2 are parallel, and it's 8 centimeters, which is fine. You can work with that, or you can just ignore it for the meantime. Finish up with this horizontal side. that you are given from B to C, 10 centimeters. You measure that 10 centimeters on your number. So in this case, guys, just take a closer look. This cannot give us the 10 that we want, which is unfortunate to us. Like this, I cannot have that 10. You see, I cannot have that 10. No matter what, if I will try to reduce like this, the 10 is no longer there. But if you were to have that 10 properly, you were going to mark it like this. You're going to measure it. Then you mark that 10 centimeters, just like this. Our 10 centimeters is approximately here. But this you are supposed to use the compass in the presentation. But here, guys, is because I cannot have that 10. You're supposed to mark everything with your compass. You guys, yours, it can open up to 10. These are softwares, guys. Do not compare us with these softwares. So this is 10 centimeters from B to the point C. So meaning say this is our C. And at C, you're supposed to have an angle of 60 degrees. And this is inside of the shape. As you can see, 60 is inside. So you can construct this side or 60. Remember how to construct 60. You need just an arc of this nature on this side. Without changing this length on this other part, you need to point here, construct back this arc like this. These two arcs, they do meet at this point. Where these two arcs do meet, that is where you are going to focus on. Meaning to say, by joining this, you are constructing an angle of 60 degrees and an angle of 120 degrees on the other side. Remember, I said this when constructing 60, you are also constructing an angle of 120. But as we need the 60 inside, that is where our major part, I mean, this one is supposed to be 60 degrees inside of the shape. So this is 60 degrees from C. So the question is that we were supposed to have from this point C 60 degrees, which is this one that we are having here. We were supposed to have a certain distance to D, and from this B, a certain distance to A. That one for A, we know it from B to A, this one, B to A, which is 8 centimeters. We know that. So we can take our measurement of 8 centimeters in that case, like the previous case, you measure that, but you are using your compass in this case. I mean, so so that you mark these points properly. But as for me, guys, as you saw previously, it was difficult. So I'm just gonna show you approximately where our 8 was supposed to be. Maybe this time it's gonna work. Let's try. Let's just try to open it. 8. It's now it can work because it can open up to 9,2. So this is our 8 centimeters here. I can even measure it here like this. But you are using your ruler. You are measuring this 8 centimeters on your ruler like this, where this from 0 to 8 on your ruler. Okay. Then with the 8 centimeters like this, you mark it back on this arc like this. That is where our 8 centimeters was. The 8 centimeters, this one that we had before. 8, yeah. This. Okay. So this is at point what? At point A. You are at point A. 8 centimeters. So I want you to be careful now, because now you're left with joining, but still on the joining part, we do not know. A, is it going to join here? A, is it going to join here? A, is it going to join here? But there's a statement that can help us that they are parallel lines, AD and BC. And from the parallel line concept, I said, if this angle is 60, the one inside is supposed to be 120, but we can't measure anything because we do not have the length of this side. But because of the 8 centimeters that we have, remember, parallel lines, they have a concept that they maintain. They maintain equal distance throughout here. There is equal distance. So with that concept or with that idea, I can simply measure the distance here because I already have it from this point to this point. We said it's 8 centimeters. I use that same distance at point C. At this point C, I mark or construct an arc of 8. So this is 8 centimeters. So this is what it means, guys. By joining these arcs here, I want you to know, by joining the back of this arc to the back of this arc, the line that we are drawing is at 90 degrees. And this line is parallel to the line that they will never meet. This line, or like this, if we join this back here of this arc to that point at A, this line that we are going to draw to that arc that we want on this side is parallel. And it will be at 90 degrees at this point. They will be parallel, they will never meet. That is the so you use the concept of your parallel lines also. What is it that you understand? So like I said, if this is 120, if this is 60, guys, this angle here will be 120, or this one will be 60 from the Z angles concept. That is for you to confirm. You can measure that to confirm if that is the concept, all right? So I want to remove this, sorry for that. So like I said, you can measure that part. If you measure, this must be 60 degrees also. That is for you to make sure that this is parallel. These two angles are supposed to be equal. That's the concept of parallel lines. These two angles are supposed to add up to 180. This angle here at point D and this angle at point C, they must add up to 180, co-interior angles. That's what parallel lines tells us. This is from our parallel lines. So that was our diagram. The one that you're given, the construction. Item 2, the locus of points equidistant from A and B. Equidistant from A and B, in between A and B. So which points, which distance are we talking about between A and B? Is simply the line bisector. Remember, I talked about this. From point B, you open more than half. This is to bisect a line. That one, it was a line bisector. So at point B, open more than half of the line, construct an arc this side, also construct an arc this side. You do the same thing at point A. So you're going to do the same thing here at point A without changing the distance on your canvas, without changing this distance. You're going to mark a point this side, mark an arc, and also mark an arc this side. You're going to also need another arc this side like this. So these two arcs, they do meet at a certain point. Where the two arcs meet, you can join. That is, you have bisected, you've divided this line into two equal parts. So this is our line bisector, locus of points equidistant from A, B, and B, and A and B. This as a line bisector. So it's the same thing also on item 3, equidistant from B and C, equidistant from B and C. This is our B and C. So you do the same thing, bisect the line BC. So you're going to open more than half of the line. So at point C, this is more than half of the line. Construct an arc on top. So you're going to have an arc on top. Construct another arc down here. You do the same thing on B. You construct an arc to meet this one that we had before, and also this side. All right, so let's just do this. We'll relate back to the point that we had at C, so that these two will intersect. So from C, remember we had got this arc. So these ones, they intersect. Also, they will intersect here on top. Okay, guys, sorry, you see this slight movement that happened here can cause a lot of effect. This slight movement that we are seeing here can cause a lot of effect. It was like this. I don't know how did it just slightly moved, but let's just hope it's not gonna affect. So this one was going to be like this. All right. So we need the point of intersection. So you will join to the point of intersection. That is the major part that you have. You join it to the point of intersection. I don't know how did that come out. How did this one happen? But anyways, we're going to join to the point of intersection of the arcs. So these two arcs and that other part. Guys, let's just hope this does not. Let's hope this didn't actually affect my, because a slight movement, guys, is gonna change everything. And I did not want it to be like that. That's why I'm trying to maintain this diagram like this. But now, guys, let me just see. This is 3, 1, 8. Just gonna use 120. Okay, let me just hope I'll remember. So it was going to be like this at the end. That was your diagram after dissecting these two. Then the question there, it was mark a point P. So this point P that we are having here is supposed to be, which is equidistant from A and B, which is that one that we got here from A and B and C. So as you can see, A and B, it's a line bisector. B and C, it's a line bisector also. So these two line bisectors, they meet at this point. Where they meet, that is the point that you're supposed to name, to mark it and name it P. Mark and label point P. Then construct a circle passing through A, B, and C. So the circle is supposed to pass through the point A to the point B to the point C. So meaning to say, for this circle to pass through this point A, B, and C, you must have the center at P. You put the needle point at the center, which is P. Just open a distance to one of the points, either to A or to B, whatever point that you want. With that distance that you've opened, guys, you can draw a circle with that distance that you've opened. And you see that the circle that you are going to draw is going to pass through the points that you are given that it must pass through. It must pass through the point B, the point A, point B, and also the point C. So that was our circle. And with this circle, that is it, guys. I'm just gonna put it this way. With the circle that we are having, question it was now, there's a region that you need to consider. Region T is such that it is nearer near to B than C. So it is nearer B than C. We are talking about distance that is nearer B than C is controlled by the line bisector. So the distance is nearer B than C. We're talking about the whole of this side, this section here. It's nearer B than C. We are considering our line bisector. But note that it is also given a condition that this same distance that we are talking about. All right. Okay, guys, very sorry for that. Needed our question back here. Sorry. I'm just gonna take our question back here. Sorry for that. All right. So the other statement, it is given that this is supposed to be nearer B than A. That's another statement. And nearer B than A. So you compare it the same way that you did that part. Nearer B than A, meaning to say you are comparing using this line now. This is the line that you are using. So which one is near to A? This side. I mean, which one is near to B? This side. Than to A. This one is nearer. This section is now near A. According to this line. Remember, the line bisector, it divides this into two equal parts. So the part that is near B is going to be this section. And they are saying this is supposed to be inside quadrilateral ABCD, shared region T. Inside quadrilateral ABCD. So this will be the region that is remaining inside the quadrilateral. You're not considering inside, not just the circle, but it must be inside the quadrilateral. So this is closer to B. It is also closer to B compared to A. Closer to B compared to C. Closer to B compared to A. That is the part that you're given there. All right. Then another part, it is now to measure and write down the radius of the circle, and that be that part that you're given. So in order for you to have the radius of the circle, you either gonna use your divider, or you take this compass, place it on P to the circle, then you can measure it, or you can use your ruler to measure that. So you're going to measure from this to the center, something like that. So here, because of the adjustments that we have made, guys, you are moving here, this and that. Remember, the moment that you just change this distance, it affects everything at the end. But from the measurement that I had, it was something like 6,3, something like that. So I want to see, I want the value that you're going to obtain. So it depends with your constructions thereafter that you are making, guys. Remember, you're supposed to use a sharp pencil. Everything is considered. So I want you to measure that side and let me know what are you obtaining, the units that you are obtaining, like what exactly are you obtaining from what you are given, or from your graph. I mean, from your construction that you made there, guys. Okay, make sure that you make your the constructions are clear. What is important is that your constructions are supposed to be clear. That is the major part. Let them be clear. Very, very clear. All right. This is section B, question number 6, where we are given answer 4 questions from this section. Each question carries 12 marks. They were given the universal set 1, 2, x is greater than 1, but less or equal to 20, meaning to say, as part of our universal set, we are talking about numbers that are bigger than 1. X is greater than 1. 1 is not involved. So I talk about 2, 3, 4, 5, 6, 7, 8, 9, and so on, up to what? Up to 20. These are the numbers in the universal set. X is of prime numbers, so meaning to say X is consisting of all prime numbers. What is a prime number? A number that is divisible by 1 and itself. Remember, when you're asked to write a number as a product of its prime factors, you're talking of the prime numbers 2, 3. Those are numbers that you're using. So we have got 2, 3, 5, 7. Also have 11. We have got 13. We also have 17, 19, but 20 is not, so up to 19. These are the prime numbers divisible by 1 and itself. There's only 1 and itself. 1 and itself. Y is an even number, so Y are even numbers, 2, 4, 6, and so on. 6, 8, 10, 12, 14, 16, 18. Remember, you are limited to 20. Then Z is representing multiple of 5. These are multiples of 5, like 5, 10, 15, 20, and so on. These are multiples of 5. So the question on item 1, it was to list all the elements in set X. So this is our set X, guys. I'm not going to repeat that. We already have our set X. Okay, we already have that X. Item 2, number of elements in Z. Z, how many? These are Z, but the question is the number. How many? 1, 2, 3, 4. You count them. There are 4 elements. Item 2, number of elements in Y. Unions. Union, you combine. Remember, I said union, you combine. But how many? Number. How many? So Y union Z, if you have to take a closer look here, I do not want us to combine. I just want us to see some of this. You don't need to combine. 1 mark, guys. Please, 1 mark. They know that you can do it direct. If you check in Z, we have the 10, which is there in Y. So we are not going to count this. We count it once. We have 20, which is also in Y. So we're not going to count this. So when you are counting, because we need the number, how many elements are there? We are going to count union. Remember, you combine. But as you combine, you don't repeat these numbers. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are 12 elements. You do not repeat the 10 and the 20 because you counted them in the set Y. So they are 12. Okay? Set P is a subset of the universal set, and P has got elements. These elements 10 and 20. It's a subset 10 and 20. If you check 10 and 20, these are the elements that I was talking about here. 10 and 20, this 10 and 20, this one, 10 and 20. These are elements which are only found on the intersection of Y and Z. They are not on, in other words, if you check, guys, there's an intersection that can happen between X, Y, and Z. Are there elements that you can take in X, Y, and Z? There's an intersection of Y and Z, 5 and 5, this one. 5 is there in Z. There's an intersection of X and Y, 2 is there. But this 10 is not there in X. We do not have it in X. It's just between this Y and Z. So meaning you say this 10 and 20, it's an intersection of Y and Z. It represents the intersection of Y and Z. But they need you to have that P as in set notation using set X, Y, and Z. So how can we involve set X in this Y and Z intersection that we're given? We can take it as what is not in X intersection to this, because we know that the intersection, there's no way it brings these elements which are here. They are supposed to be also appearing in what is there, what is not in X. They are not in X, these elements, 10, 10, and 20. They are not in X, so that is X complement. But it is intersection of these two. So that is the set notation representing P in terms of X, Y, and so P is equal to this set. So you can write it in any other way that you do understand, as long it represents where 10 and 20 is. That is what they are saying there. All right. Item 2, you were given to item B, that is B item 1, to solve this inequality. Minus 3 is less than 2x plus 1. Okay, less than like this, 7. So you can read it from the middle expression that you're given here. 2x plus 1 is greater than this. If you understand it that way, it means there's an inequality there representing 2x plus 1, which is greater than 3. And there's also an inequality of the same 2x plus 1. But this 2x plus 1 is less than or equal to 7. So there are two inequalities that's simultaneous. You can solve them. This, to the other hand, becomes a negative. So that's negative 3, negative 1, which is negative 4 is less than 2x. Divided by 2 by 2. So x is greater than 2 into this. That's a negative 2. You do the same thing, transpose this to the other side. That becomes a negative 1. So meaning to say 2x is less than or equal to 7 minus 1, which is 6. Divided by 2, divided by 2. So x is less than or equal to 3. So remember, you're supposed to combine this in the format where x is greater than the smaller value or bigger than whatever that you're given there. So it's greater than minus 2, the same x. But the same x is less than or equal to 3. So this becomes a single solution like that. From here, you're now given, give the integral values which satisfy the inequality in item 1. The integral value which satisfy these integers in within this interval. The integers, positive or negative, whole numbers. Minus 2 is not part of our solution. That is what we are given in this case. If you were to represent on a number line, let's say you want to put it like this. Minus 2 is not part of what we do not want it. We want integers, minus 1, 0, 1, 2, and so on. Minus 2 is not there. X is bigger than that. So you do not take the minus 2. So the X that we are talking about is supposed to be the element -1, 0, 1, 2, up to 3. So 3 is involved, x is less than or equal to 3, which means 3 is also part of this set. You're supposed to consider your B in this case. So that is how the question was supposed to be done. So you must understand your question, understand like the concept of the question. What is the concept there? What is the concept? All right, so considering question 7, we are given in this case A, which is a matrix x3, 1, 2. Then item 1, you're asked to find the value of x if the determinant of A is 5. So we are given that the determinant of this is equal to 5. The determinant of A is equal to 5. So the question is, how do you calculate this determinant? Remember, your determinant is the product of what is in this major diagonal, the x and the 2. That is 2 times x, or x times 2, minus what is in the minor diagonal. This is the minor, the one that has got 3 and 1. So you multiply this 3 times 1. So this is how you are supposed to calculate your determinant. But in calculating that determinant, you are given that it is equal to 5. So what have you formed? You have formed an equation. This is now an equation. More that you say it is equal to, it is now an equation. So whenever you're dealing with an equation, what are you supposed to do? To solve that equation for the unknown. So you can solve for x. 2 times x, that's 2x, minus 3 times 1, which is 3, is equal to 5. I can transpose this, a linear equation, so I can transpose the 3. Negative 3 becomes a positive 3. So 2x is equal to 5 plus 3, which is 8. So that means that will be 8 divided by 2 by 2. Our x was going to be what? 4 at the end. So in this case, for this determinant to be equal to 4, our x here is, for this determinant to be equal to 5, our x is supposed to be 4. For this determinant to be 5, this x is supposed to be equal to 4. And after that, the question is on item 2, it was to determine the inverse of A. Remember, the inverse, you determine it from the determinant that you obtained. So the item 2 is just a continuation. Already the determinant, you have it. So the inverse of A, remember, it's 1 over the determinant of A. Then what are you going to do? In the major diagonal, you change the position. So that will be 2 and 4. Then the minor diagonal, this part here, you multiply it by a negative. So it's negative times this, which is negative 3, negative times 1, which is negative 1. All right. Just like that. B, solve the simultaneous equations. You can use elimination, you can use substitution. Guys, it's up to you. We have worked with so many methods. So in this case, you can just use elimination. Let's say you want to eliminate x. You can multiply the equation on top, just interchange 1 multiplies on top, 4 below. That is times 1 times 4. 1 times 4, that will be 4x plus 3y is equal to 6. You are multiplying by 1, nothing changes by 4. 4 times 1, 4x, 4 times 2, that will be 8y is equal to 4 times minus 1, that's minus 4. How can I eliminate x? Because on x, it is the same. I can simply subtract the second equation from the first one. That's 4 minus 4, that's a 0. You have eliminated x is no longer there. 3y minus 8y, that is minus 5y, is equal to 6 minus 2. So that is 6 minus minus 4. A minus and minus, that's a plus, which will be a 10. So this is equal to 10 divided by negative 5 divided by negative 5. So y was going to be equal to a minus 2. With this, you can also eliminate the part of y if you want, or you can substitute the value of y that you obtained in any of these equations. I'm going to choose equation 2. It's a choice. Anyway, you can use any method. This is equal to minus 1 and y is minus 2. So in place of y, we're going to substitute minus 2. So that is x 2 times minus 2, that's minus 4, is equal to minus 1. Let's transpose the minus 4, it becomes a positive 4 on this side. So x was going to be minus 1 plus 4, which is simply 4 minus 1, which is equal to 3. So in this case, y was going to be equivalent. X was going to be 3 and y be a negative 2. Then on C, we are given, in this diagram, we have got P, Q, R, and S. These are the points P, Q, R, S on the circumference of the circle. And we're given that QS is the diameter. This QS that you're given is the diameter. So remember that a diameter subtends an angle of 90 degrees. If you're given a diameter, if this QS is a diameter at the circumference, it must create an angle of 90 degrees, meaning to say there's 90 degrees at R. All right, that is what you're given. Then from there, we're given PT is parallel to QS. These two lines are parallel. You can talk of the co-interior angles adding up to 180 degrees. This is a co-interior again. That is what we have. So many things. Then we've got these two angles. So the question was, item 1. State briefly why QRS is equal to 90. This angle that I've talked about, that is 90 degrees. Why is it that it's 90 degrees? On a condition where you're given to state briefly or to explain this and that, they want you to explain giving a theorem. What is the theorem that is backing up this to be 90 degrees? Remember our theorem, angle subtended by a diameter. The angle subtended, because angle subtended by a diameter. So as long as it is subtended by a diameter, equals 90 degrees. It equals to 90 degrees at the circumference of the circle. So it must be at the circumference of the circle. So meaning to say, as it is at the circumference of the circle, from the diameter, it will be 90 degrees. All right. So remember, we've got a 34 degrees. This is a 90 degrees, and this is 68 degrees according to our diagram. Then from this, find QSR. All right, let's see. QSR, which is this angle Q, to S to R, which is this angle here. Angles in a triangle, remember, they add up to 180. So you can subtract the 90 and the 34 from 180, or simply 90 minus 34. Or you can subtract these two angles, the 34 degrees and the 90 degrees, from 180 degrees angles in a triangle. So that was going to give us 56, or just 90 minus 34, because these two angles, they're supposed to add up to 90. So 90 minus 34, these two angles adding up to 90 degrees. Find STP. STP, this angle that you're given. Remember, I talked about the parallel lines. If these two lines are parallel, these are co-interior angles, and co-interior angles, they are supplemented, they add up to 180. So to find this angle, it was simply 180 degrees minus the 68 degrees that you're given, and that was going to give us 112. All right. From this, okay, now number 8. So section B was quite easy, guys. Why people are complaining? I don't know. Guys, ZIMSEC is trying to just let us pass the way that it is here. Okay, let's see. A, find the value of P by substituting this. We can find P, substitute the value of X corresponding to P in this equation. We're given our equation. So you're going to substitute Y is equal to, in place of X, that is minus 3 squared plus minus 3 minus 3. This is your calculator, guys. Use your calculator. Why are you entering exam with a calculator that you do not use? Use it. That is where the calculator is to be used. Okay? Q, when this is a 0, substitute in place of X again, that was going to give us a negative 3. So this is 3. This is negative 3. B, item 1, we are asked to draw this graph on the sheet of graph paper using a scale of 2 centimeters to represent 1 unit on the x-axis and 2 centimeters to 2 units on the y-axis. But you're not given the interval like x from this to this, y from this. So you just work with your scale, with your table. As you can see, x is from -4 up to +3, because you're not given, guys, that. So you have to be also very, very careful. So on the X, you're asked 2 centimeters to represent 1 unit, and we need -4 up to something like a 3 there. So you can just take, that's 0, 1, 2, 3, 4. I think we're going to be able to win. -1, -2, -3, -4, -5. Okay, on the y-axis, remember it was 2 centimeters to represent 2 units. Be careful with the scale, 2 centimeters to 2 units on the y-axis. Be careful with the scale. So that's -2, -4, and so on. So you're going to have this -2, -4, -6, -8, -10. I think that can accommodate our values. The same 2, 4, 6, 8, and so on. So that is what you're going to have on the y-axis. So this also can accommodate our values that you're given. So you simply mark your points, guys. This is direct, straightforward, actually. Like you just take -3, the -4 on x versus the 9 on y. So that's -4 on x. 9 is going to be in between 8 and 10. So -4 straight between 8 and 10. You're going to count 5 boxes. 1, 2, 3, 4, 5. Somewhere there. All right, guys, just be careful there. Mark your points properly. We've got -3 versus 3. So remember, another point was -3 versus 3, the one that you calculated. We need to say if it is wrong, it affects everything. So on top of -3, we just need at 3 somewhere there. So at 3, which is between 2 and what? 2 and 4, somewhere there. 1, 2, 3, 4, 5. So that's going to be -3 versus 3. The other point, it was -2 and -1. Down here, 1, 2, that's when I 1, 2, 3. Sorry guys, 1, 2, 3, 4, 5, somewhere there. The other one, it was -1 and -3, remember? -1 and -3, 1, 2, 3, 4, 5. So guys, just be careful, mark your points. Again, 0 versus -3. 1, 2, 3, 4, 5. That's 0 versus -3. And we had 1 versus -1. 1, 2, 3, 4, 5. And we had 2 versus a 3, which is 1, 2, 3, 4, 5. That's 2 versus 3. And a 3, it was versus a 9, which is on top, above 3 there on 9, somewhere there. All right, so that'll be 1, 2, 3, 4, 5. In between 8 and 10 lies a 9. So these are the major points that you're supposed to indicate. Then you can join. So in this case, guys, as for me, it's not going to be that smooth, but you're supposed to have a smooth curve, guys, as you are drawing. So as for me, guys, I'm just going to try. But you are supposed to have a smooth curve. Join your points so that you obtain a smooth curve. All right, so let's just say we have got something like this. All right, so like I said, guys, mine is not as smooth as what it was supposed to be like. Write your equation. Y is equal to x squared plus x minus 3. Do not forget to write the equation. Labeling of the x-axis and the y-axis must be done also. So with this equation, the question was to draw the equation, draw the line of symmetry, actually, of the curve. The line of symmetry is the equation of the axis of symmetry, which is the line which divides our graph into 2 equal parts. So how can I obtain this equation if I do not know exactly where it is? I said you take the x values corresponding in a horizontal line. The corresponding x values corresponding in a horizontal line, like this one. At this point, if you take this horizontal line here, their x values, it's a line. Here, these are x values correspond, it's a horizontal again. Here, these are x values, this horizontal, all these are horizontal lines. So when I'm saying the values of x, I'm saying what is the x here at this point? It's -1. What is the x here? It's a 0. If you take these 2 points, x is equal to, you add -1 plus 0 over 2. That is the value of x at the axis of symmetry or the line of symmetry. Okay, let's consider this horizontal line. When it meets with the graph, what is the x here? It's -2. What is the x here? It's 1. You take those values, x will be equal to the average of those values, -2 plus 1 over 2. You're going to obtain -0.5. Do it also on this line. There is -3. There is a 2. You add those values, divide by 2. So as we can see, on all these lines that we are talking about, it is at x is equal to -0.5. So you draw the equation of the line, x is equal to -0.5. So guys, just forgive me of these lines. I'm going to leave it there. I'm going to leave them like that, okay? So -0.5 is in between 0 and -1. That will be 1, 2, 3, 4, 5, somewhere there. You draw your axis of symmetry, which is a vertical line. You can also draw this as a broken line. That one, it's up to you. But what is important is that you're supposed to indicate that line and also the equation x is equal to -0.5. Like I said, you can have the equation. This is at the turning point of the graph. So you can take from the x values along the horizontal line, what is it that you are having? The x on the x, what is the x there? You take the average. The average of those values is the value of x at the turning point, which is the at the line of symmetry. Use the graph to find item 1, the equation of the line of symmetry. We just draw the line of symmetry of the graph, then find the equation of the line of skies. Already we have found our equation, so we've answered 2 questions at the same time here, to draw and the equation. Then item 2, find the coordinates of the minimum point of the curve. So the minimum point, as you can see from our graph, truly we have got a minimum point. Our graph, it turns this side. There's a minimum turning point. So at the turning point, whether it's maximum or it's minimum, the value of the minimum turning point, you take it from your curve, which is y is equal to x squared plus x minus 3. Just substitute the value of x at the axis of symmetry. What is the x at the axis? Suppose that x at the axis of symmetry is the x at the turning point. So you just substitute the value of x that you are given, which is the -0.5 at the axis of symmetry. Y was going to be equivalent to -3.25. So this is the value actually that corresponds at the turning point here. At the turning point, like if we take it to the graph. So because of the smoothness, because guys, remember you're using a free hand, sometimes it's not smooth. So it is best that you substitute into the equation so that you do not have any error from there. So that was our item 2 of question C. All right, so that's our C item 2. So in this case, the point, because the question needs us to determine, take note, the coordinates. So you state the x value, you also state the y value. So remember, x at the turning point is the x at the axis of symmetry. And the y is the one that we obtained by substituting this value of x. The y is going to be -3.25. All right. Solve the equation. This equation, as you can see, x squared plus x minus 3. It is our graph. Y is equal to x squared plus x minus 3. So they are saying this whole part of our graph, which was representing y before, now it is equal to -2. So you simply draw the line of y is equal to -2, where this line of y is equal to -2 meets with our graph. That is where we are going to take our solution. So this is the line of y is equal to -2. I can just draw it. I can just draw it, the broken line where it passes the line, the point -2 horizontal like this. That is the line of y is equal to -2. So where it meets with this graph, you take the values straight with your ruler to the x-axis. There's a value there. Straight with your ruler to the x-axis, there's a value that will correspond. So mine there, it was something like 0.6, and this one minus 1.7. So just take proper, remember guys, it's on your graph. So make sure that also your graph is what is smooth. So in this case, guys, because of these softwares, we can't have exact values, but it was going to be approximating 1.7, or x is equal to 0.6. So it's going to be 0.6 or 0.7, somewhere there, depending with your graph. This is depending with the graph that you are having. That is how you could have answered this question on the minimum value to determine the minimum value of this graph. All right. So guys, let's do revise as much questions as we can. All right. So sorry for that. I just want to remove one thing here because it's going to affect me, guys, as I am working. No problem. Sorry for that. So this is it. Number 9. In the survey, there are 80 motorists which were asked the number of hours their journey took. The results were used to draw a cumulative frequency. It's already, we have drawn the cumulative frequency curve. This is it. But the question here is that from this cumulative frequency curve, use that graph to answer the following questions. A, item 1, complete the frequency. The frequency, not cumulative. This is frequency. The table shows frequency. The graph is not showing frequency, no. It is showing the cumulative frequency. Remember, the cumulative frequency, these were increasing as you were taking them. You're adding one frequency to another. Like if the first one is 20, you start with 20, then you add 20 plus 25, which is 45. You add that 45 to 19 and so on, which is 64. These were the values that we're actually having as the cumulative frequency. If you check the cumulative frequency, would have the 0 there, 2 versus a 20 in this case. This one is 2 versus 20. The 3, this one, will correspond with 45. If you check, that was actually correspond, this 3 here. If you check it there, it was corresponding with 45. The 3 there was corresponding with a 45, if you take properly from your graph. So that is the cumulative frequencies. But we do not need the cumulative, we need the frequencies. So how do you take the frequency? You simply subtract. If you are dealing with the class of 0 to 2, you take from 2, the maximum at 2 here, at 2. What is the maximum value? It's 20. Remember, it's 0 to 2. So you subtract in between 0 and 2. So there's a 20. There is a 0 there. So that is 20 minus a 0, which was going to give us a 20. The same thing from 2 to 3. You focus with where 2 is and where 3 is. 2 is at 20. 3 is at 45. The difference that you're having there, 45 and 20. That is what we're doing. 45 minus 20. That is the 25. The same if you move to 3 and 4. Check there. 3 is here to 4. So you have to check what is happening at 4. So going straight at 4, the value that was going to correspond was a 64 there. It was corresponding at 64 if you count it properly. Then the difference now between these 2 points, 3 and 4, corresponds to the difference here, 64 and 45. That is how you're finding this. 64 minus 45. You obtain 19 and so on. So meaning say from 4 to 5, you can do the same thing because you're asked to copy and complete this. So from 4 to 5, you're focusing with these 2 points, 4 and 5. What is corresponding? Remember, at this 4, okay, at 4, we never talked about this. They need us from 4 to 5. Not this one, from 4 to 5. Between not this 6, this is 6. So we need this one, 4 to 5. I'm seeing that we never talked about this. Okay, 4 and 5, this one. So 4 is already there. 4 here is corresponding to this 64. 5, you take it straight, it was going to correspond somewhere to 72. So 5 is there corresponding at 72. So guys, you just take this properly on your graph. It was corresponding at 72. So the difference between this 4 and 5 is the difference between these 2 points, 72 and what? And 64. So that will be 72 minus 64, which is 8. Between 5 and 6, you consider the point 5, 6. Where is 5 and 6? That is where you consider these 2 points, 5 and 6. Remember, at 5, it's 72. At 6, if you have to take it straight there to the corresponding point, at 6, it was corresponding at 76. The point there, it was approximately at 76. So that was 76, the value that we are having there. So meaning to say we're going to have the difference of 76 and 72, which is a 4. Then the last one is 6 to 8. You are combining 6 to 8. We are not counting 7. No, 7 is not taken. You need 8. At 8, it corresponds with 80. So what is the difference between these 6 that we are seeing? Remember, at 6, it was corresponding at 76. So it's 80 minus 76. So that was going to be 80 minus 76, which is a difference of 4. That is how we're going to answer this. You can take it from the table. So just make sure you take it properly. This graph, guys, it was not that clear, but I think those were the points that were corresponding. With those points, you can calculate. These are frequencies, not frequency density. So if you add, those are the ones that will correspond 20, you add 45, 64, and so on, up to 80. Remember how you were finding these cumulative frequencies. So if you add everything here, it must add up to 80. Okay. Then from there, calculate an estimate of the mean number of hours of the 80 motorists took, giving your answer to the nearest hour. All right. So let's start by mean first before you talk about the conversion thereafter. So remember the mean, you consider the sum of the class centers to the frequency, the product. So you need the class center, which is the lower class plus the upper class divided by 2. Class center, so you add 0 plus 2 divided by 2, which will be a 1. 2 plus 3, which is 2 plus 3 over 2. That will be 2,5, and so on. So you add, these are the, you add divided by 2, add divided by 2, and so on. Add divided by 2, add divided by 2. That is how you determine the class center. So it's class center times frequency, 1 times 20, plus the class center from 2 to 3, which is 2,5, times the frequency there, which is 25. You take the frequencies this time. From 3 to 4, 3,5. You add, divide by 2, 3,5, times the frequency, which is 19. 4 to 5, you add 4 plus 5, which is 9, divided by 2, which is 4,5, times 8. So that's 4,5 times 8. You do the same thing, 5 to 6. You add these two, 5 plus 6, 11, divided by 2, which is 5,5. So that was going to be 5,5 times 4. You do the same thing, the last class, 6 to 8, you add 6 plus 8 divided by 2, that's 14 divided by 2, which is 7. So that's 7 times 4. Everything that you have here, you divide it to the total frequency that you are given. So instead of adding everything, you are told these are 80 motorists that you are given. So you just divide by 80. So combine everything there. That's your calculator, guys. Like I said before, that is going to be 235 over 80, which is equal to 2,9375 hours. But the question is, you're supposed to give to the nearest hour. So this time to the nearest hour, to the nearest whole number. The 9 was going to change this 2 into a 3. So that means we have got 3 hours to the nearest hour. Remember, a number bigger than or equal to 4, equal to 5, I mean, changes the next value. So that was going to be our mean value. The median, find the median. So the median, we can obtain it from the graph. Remember, that is half of the distribution, the median. So our distribution adds to 80. So we can use half of n plus 1, half of the distribution. So that's half of 80 plus 1, which is half of 81, which was going to be 40,5. So this is 40,5. It's a position that you are considering between 40,5. So 40,5, 40. Then remember, each box, guys, it was like 40, 41. So 40,5 is in between 40 and 4, in between. I'm talking about a box in between. You draw it straight to your graph using your ruler. Then you take it straight from that point down to the graph. So this was going to correspond somewhere to 2,8 there as the value of the median, the actual value. This is the position, but the median will be the value that is corresponding from the horizontal axis. So it was something like 2,8 hours. Remember, the time there is in hours. So that is how you can determine the median. Then item 4, the probability that 2 motorists chosen at random took, they took more than 5 hours, but less than or equal to 7 hours. In normal cases, this condition, we are used to have it from the table, but we do not have on our table here the presentation of 5 to 7 hours. So what are you going to do? You use your graph now from 5 to 7 hours, from 5 to 7 hours. Remember, at 5 hours, this value here was corresponding to 72. If you take at 7 hours straight at 7 hours, you see that the value that will correspond there, it was gonna be a 78 there. It was gonna be a 76 actually. More than that is simply just above the 70, the 76. Remember, 76 was at 2, that was gonna be 78 there. Just 2 boxes there. That's 78. So meaning to say, you are considering between what we had at 5, which was 72, and the 70. That's approximately 78 there, guys, according to our graph. There, guys, it's just 2 boxes there. That's 1, 2. That's 1, 2 there. So it's going to be 78 minus 72. So the difference there, 78 minus 72, there's a difference of how many? That is the question. There are 6 people on that region. There are 6 motorists, but there are 2 who are being taken. So it's 6 out of the total 80 times the other one. If you take this is the first one, then the other one, it will be 5 out of 79. You subtract 1 on the total. Remember, we talked about this calculation, but there we were just supposed to refer from our graph first. So it was going to be something like 3 over 632 as a decimal. If you want to write as a decimal, 0, something like 0, 0.04, 0, 0.047, like that, guys. If you want to write as a decimal, you can just leave it as a fraction, 3 over 632. So they were supposed to be careful from 5 to 7. So we needed at 5 hours, which was 72, and at 7 hours, which was 7, the difference there. So this one, instead of taking it from the table, we are going to take it from the graph. Just like, remember, this graph was drawn, the table was taken from the graph. So you just do the same way because it was taken from what? It was taken from the graph, okay? Sorry for that. Then on this other question, which is B, they are saying this information, it was just given like the marks and the frequency. Then they're saying if not, it's just an assumption. If we are to do this, what's going to happen? If the information above were to be represented on a histogram, they never said represent. If it was, calculate the heights of the first 3 class intervals. Calculate the heights of the first 3. The heights, what is it that you use on a histogram as the height? It is the frequency density. So the question is simply asking you to calculate the frequency density of the first 3 classes. That is the question there. So how do you calculate the frequency density? That is the height. So the frequency density, remember, it's frequency over the class width, where class width is the difference between the upper class minus the lower class. So meaning to say for the first class, the frequency density was going to be the frequency of this class, which is 2. The class width is subtract 21 minus 17. So that's 21 minus 17, which was going to be 2 over 20 minus 0.5. So it was going to be over 4, which is 0.5. So that is the height of this class. The second one, the frequency, so it's going to be frequency density is frequency 3 over the frequency density, over the class width 24 minus 21. So that's 24 minus 21, which is 3. So 3 over 3 is 1, and so on. For the third class, you do the same thing. The frequency density is going to be the frequency of 9 over the frequency density 27 minus 24. So that is a difference of 3. 9 divided by 3, which is a 3. So they wanted the frequency densities for the first class, but instead they asked these as the heights is the same thing. Then we are given on number 10 a vector where we are given in the diagram OA BC is a parallelogram. Remember the properties. If this is 2B, also this side parallel is supposed to be the same. We are supposed to have a vector of 2B this side. If this is 2A, this side also is going to have 2A with the same direction going up. And we are given that R, S and R is S is the midpoint of AB, R is the midpoint of BC. So this is the midpoint. And also this is the midpoint. Express the following vectors in terms of A and or B. Vector AS from A to S. Remember, S is the midpoint, and we have got the vector AB, which is 2B, the one that we have there. So this vector AS is simply half of vector AB, which is simply half of this vector 2B that we are given. So half of 2B was going to be vector B. So from A to S, there's vector B. From S to B, there's vector B. Remember the concept there of a midpoint. Okay, then item 2, vector OS. So vector OS, we can take the root that we can consider from O to S. Since we have AS that we calculated, OS is going to be equal to OA plus AS. From O to A and A to S. That's OS. Where OA, vector O to A is 2A. That is 2A plus AS, vector AS, which is B, the one that we calculated. Okay. Then let's consider item 3, vector OR. From O to R, we're going to consider again the distance given. So remember, if you consider O to R, this is it. So you're going to have OC, CR. So CR is just the remember, R is the midpoint. So CR, just like AS, it is half of this CB, which is half of 2A. So half of 2A is equal to A. This is A. This is also A. So we can calculate this vector from O to R because the root is going to be OC plus CR. All right. That is our vector OR in this case. Vector OR is going to be OC plus CR, which is from O to C, that is 2B, plus from C to R, which is A. So this can be also written as A plus 2B if you want, or you can just leave it as 2B plus A. That is actually up to you in terms of the presentations thereafter, the way that you want to have it. All right. Then we are given vector AR from A to R, that is here. A to R like this. Remember, we have OR, so we can calculate our vector AR using A to O, that is vector AO plus OR. Since we calculated vector OR, we have it, or we can use A to O to C, and C to R. It's up to you. From A to O, that is from A to O, we are opposing the vector. That will be minus 2A plus OR, we already have this vector OR here that we calculated, which is 2b plus a. Collect the like terms. We've got vector A minus 2 plus 1, that is minus 1. So we've got minus a plus 2b. Just like that. So we've got our vector AR there. Then on this other part, you're given OS and this AR, they intersected T, and we're given AT. Show that OT is equal to this. Let's start by this. AT is equal to HAR. Let's start by that. AT, that statement alone, what does it mean? Okay, what does it mean? So B, we are given AT is equal to HAR. What does it mean? It simply means H times vector AR, which we calculated here. Remember, it was minus A plus 2B. So you can calculate this, which is minus HA, H times 2B, which is 2HB. This is our vector AT from the given information, not what we asked to calculate. The question is calculate or express this or show that OT is going to be like this. So you need to calculate OT from this AT that we have. It must be a continuation. Using this AT, we can calculate OT. So from O to T, that is the rule that we want. From O to T. But AT is supposed to be there. So it's supposed to be OA plus AT. All right. So therefore, OT, from this, we're going to have OA plus AT, whereby we are given OA from our diagram following the direction. That will be a positive. So that's 2A plus AT. AT we calculated already. That is minus HA plus 2HB. Remember, if the vectors are the same, we can factor that common vector. So therefore, our vector O2, by factoring out our vector A, which is common, 2A divided by A, we're going to remain with 2, minus HA divided to this A, we're going to remain with minus H. Okay, that's plus 2HB. So we have got our vector OT, which is the one that we are asked to show. From the vector, from this part, C, given that OT is KOS, express OT in terms of this. We're already given this OS. We calculated OS before. We have this OS is 2A plus B. And we are given that OT on this item, which is item C, we are given that OT is equal to KOS. So it's just substituting. So OT is going to be K times the vector OS. Remember, our vector OS 2A plus B, we calculated this. So that was going to be 2A plus B. So let's multiply and see what you're going to have. K times 2A, that's 2KA, K times B, which is going to be KB. So this is our vector OT in terms of what we are given. A is there, B is there, K is also there. Then from this vector, we are now asked to give, like using these two expressions of OT for OT. The first one on item B and the second one on item C. Find the value of H and the value of K. So remember, if these two vectors are equal, vector OT and vector OT, we can calculate the value of these unknown values, the constants H and K, from equal vectors. OT is equal to this. We take this OT and this OT. Where there is vector A, you consider there. So the first OT, where there is vector A, the constant affecting the scalar that is there is 2 minus H. it must be equal to the scalar here affecting vector A, which is 2k. So here we are equating the coefficients of vector A. We have formed an equation. Do the same thing from the coefficients of vector B, where there is vector B from the first vector, this is a vector B, the coefficient of vector B is 2h, which is equal to the coefficient of vector B on the second equation, positive k. That's another equation. You formed two equations from the vectors, which are the same, vector A, vector A, vector B, vector B. How to solve this equation? It's in your hands. You're going to use elimination, substitution, it's up to you. But as you can see, we can take advantage of the substitution because k is already the subject. K is equal to h. So I can simply substitute equation 2 into equation 1 instead. I can just substitute this into equation 1. Where there is a k, I'm going to substitute this to h. So that's 2 minus h is equal to 2 times k, where our k is equal to 2h. This is an equation in terms of h. We can solve for h. These are simultaneous equations. Solve the way that you want. So you can transpose minus h, this side becomes a positive h. So 2 is equal to 5h divided by 5. So h was going to be 2 over 5. So with the h, we can calculate our k. Remember, from the second equation, k is equal to 2h. So you can just substitute the h that we calculated. Remember, our h is 2 over 5. So substitute 2 over 5. That is, obtain the value of k. 2 times 2, which is 4 over 5. So that's the value of k, which is going to be 4 over 5. That's how you can calculate this. You can use any method. These are simultaneous equations. They are in your hands. Any method that you can use from there. Then from these two constants, they are now asking us to find the ratio of TR over AR. I said before, this ratio, in order for you to have this ratio, find where they explained something about these ratios before. If you take a closer look, they explained where there is this R here, AR here. There's something about AR here on statement B. AT is equal to HAR. This statement is alone. This statement alone is enough for us to have this ratio that we are being given there, because we are given on this statement, all right, that is AT is equal to HAR. And we calculated H, remember, we got our H. When we calculated our H on this part, let me just remove this. There's a lot of things here. When we calculated this H, we got 2 over 5. This is our H. So let's substitute and try to make a meaning of this statement. If AT is equal to 2 over 5, representing H, and is 2 over 5 of AR like this, what does it mean from our diagram here if AT is 2 over 5 of AR? You analyze it from the diagram now. This is your diagram. Let's analyze it from the diagram, this ratio that we have. AT is 2 over 5 of AR. What does it mean? It means AT, remember, occupies two parts from A to T. It carries 2 parts of the 5 parts AR is having. AR, the whole of AR is carrying 5 parts. So if the whole of AR, this one, carries 5 parts, what about from T to R? 5 minus 2, which is 3. So meaning to say we are remaining with 2 parts. So that if you add the 2 and the 3, you obtain the 5. So now we can determine our ratio from these 2 and 3. Because the question there on E is to determine the ratio of TR, let's go back to our question, TR over AR. So from this statement, let's find our ratio of TR over AR. So the ratio of TR over AR can be determined because we have a distance from T to R. How many units according to that is 3 units. From A to R, how many units? 2 plus 3, which is 5. So that will be 3 over 5. You can relate from a statement or a ratio that you calculated before or that you were given before. From that statement or ratio that you are given, you can use it to answer that question. That is how easier or how easier you can work from what you calculated or what was given before. Then 11, it is answer all of these questions on a sheet of graph paper. Use a scale of 2 centimeters to represent 2 units on both axes. We are not given like the range, the values of X and Y. So it was going to be difficult because you draw, then you see, okay, this is not it. You start again. So be very careful. Just try to study the points also, like what you're given from X, 1, 4, 2. These are the values of X, and considering on the images there, X is also going to the -3, the -12, the -6. The Y is -9. So just make sure the -12 is there. All these bigger values there, they're also involved because you're not given an interval. But in a normal circumstance, guys, you're supposed to be given an interval. Let's be honest on that. They are supposed to give you an interval that you work from, or the interval that you can relate from, not just to work out something that you do not have an interval, or that you do not, where is it coming, or where is it even going? You must have an interval showing the values of X, where are they taken from, and where are they also ending these values of X that you are given. So anyways, let's see. We are given our X values. I mean, it was just scale 2 centimeters to 2 units on both axes. So let's try. I have 0, 2, 4, 6, 8, and so on. -2, -4, -6, -8, -10, and the -12. So the same thing here, -2, -4, -6, -8, -10. I think we're gonna accommodate those values better. So you must be careful when it is like that, guys, because you do not have option there. You are not given the interval, like take these values of X from this value to this. No, you're not given that. So you're supposed to be careful. So from there, you're supposed to mark points that you are given. The first question was to draw and label triangle X, Y, Z, where we are given X being 1, 1, 4, 1, 2, 3. So you're going to mark the points X, Y, Z. That's X being 1, 1. So X being 1, 1, it's in between the 1 here on Y. So it's going to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Somewhere there. So you're going to name this X. Then Y between 4 and 1. Ooh, that will be somewhere there. That is the part of Y. Then Z was 2, 3. So it's going to be 1, 2, 3, 4, 5. Somewhere there. We have got our Z. Then join these points that you have or that you are given. So you're going to join. Sorry, I'm joining the wrong part here. X to Y, the Z to X, and also this, just something like this, guys. Just make sure you join your points proper like that. Then we are also given from this B, triangle B is mapped onto, triangle XYZ is mapped onto triangle X1, Y1, Z1 by rotation M. which is represented by this matrix code. Guys, we're going to take your matrix times object. Remember, it must give us the image. So we're doing the calculations, we are given the matrix, and we have got your object. So in this case, you are going to multiply matrix times object is equal to image. So we're given the matrix 1, 1, minus 1, 2. The object is the triangle XYZ, where we are given that X was 1, 1, Y, remember it was 4, 1, Z, it was 2, 3. Write them as point, then you multiply row by column concept. 1 times 1, which is 1, plus minus 1 times 2, which minus 1 times 1, which is minus 1. This row to this column, that will be 1 and the 4, which is the 4, the minus 1 and the 1, that will be minus 1. 1 to this column, that will be a 2. The minus 1 and the 3 will be a minus 3. So we move on to this row, start back these columns again. So that is 1 and 1, which is 1, plus 2 and 1, which is 2. 1 and 4, which is 4, 2 and 1, which is 2, and so on. The 1 and the 2 here, which is 2. The 2 and the 3 multiply, that is going to be a 6. So add these values. Okay, 1 plus minus 1, that's a minus. 1 minus 1, that's a 0. 4 minus 1, which is 3. 2 minus 3, which is minus 1. Add, that's 3, 6, 8. So these are the coordinates of the image x1, which is 0, 3. There we're going to have y1, which is 3, 6. And z1, which is minus 1, 8. So you mark the points that you've got your image. 0, 3. First point is going to be 0 versus 3. That's in between here, 0 versus 3, which will be our x1. And we also have y1, 3 versus 6. That's 3 versus 6. So 6 somewhere there. 1, 2, 3, 4, 5. So it's 3 versus 6, which becomes y1. And we also have z1 minus 1, 8. Minus 1 versus 8. All right, so 8 somewhere here, then minus 1 in between. That'll be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Somewhere there. That'll be our Z1. So with this, guys, we can have our image from what you are given. And I have your triangle as we are given this matrix. So matrix times object, remember, it is equal to the image. So all this working, you're not going to erase it. You must have this working, all right? You just need to have space, but you must keep all the working that you are having there. Okay, matrix times object equals to the image. The same thing on C, triangle x1 that is mapped onto this by a 90 degrees anti-clockwise. It's a rotation, this one. About minus 2, 0. There's a center there. So you also do same thing to draw this. So that is 90 degrees anti-clockwise. And you are given the center, which is the center minus 2, 0. So remember, if the center is involved, you must remove first center. But let's talk about the matrix of a 90 degrees anti-clockwise. Remember, that is the 0, 1, minus 1, 0. You must know your matrices. Remember, I talked about this on the introduction. Go through the video on rotation, working with matrices. So before you use this, because the center is not 0, 0, we cannot use this matrix as it is. We must subtract the center from the image x, y, z that we are given. Remember, our x, it was 1, 1, y, it was 4, 1, our z, it was 2, 3. You remove or subtract the center first. So that's 1 minus minus 3. Minus minus, that's a plus. 1 minus minus 2, sorry, which is 3. 4 minus minus, that's a plus, which is 6. 2 and 2, which is 4. 1 minus 0, that's 1. 1 minus 0, that's 1. 3, and so on. So this is it. We removed the center. Now we can use the matrix of rotation to multiply this. If you multiply this, you still consider your row by column. But this time, so you can see, guys, 0 is multiplying the top. That's 0 times 3, which is 0. 0 times 6, 0 times... So you simply see minus 1 is going to multiply these numbers. Or you can just multiply, guys, 0 times 3, which is 0, minus 1 times 3, minus 1 times 1. You do the same, 0 and 6, minus 1 and 1, 0 and 4, minus 1 and 3. You do that. Then you can combine. After this, you combine, you do this, to this, back to the first column. 1 versus 3, that is 3, plus 0 and 1, that's a 0. 1 and 6, 0 and 1, 1 and a 4, 0 and a 3. You add. So this was going to be 0 and minus 1, which is minus 1, 3, minus 1, 6. You add this, that's minus 3, 4. So instead, you're supposed to just write this here as it is, like that. It's up to you guys. So this is not our image, no. This is the image at center 0, 0, not at center minus 2, 0. Remember, you removed the center before, so you must add that center that you removed before. So by adding minus 1 to minus 2 gives us minus 3. Minus 1 to 2, minus 3, minus 2, and minus 3, minus 5, 3, and 0, that's 3, 6, 4, and so you add these. This is the image after adding whatever that you're obtaining, which is our x2, minus 3, 3. You move on to y2, minus 3, 6, z2, minus 5, 4. That is your image that you are supposed to use there and draw your given triangle. So you're now marking the points z2, minus 3, x2, minus 3, 3, minus 3 versus 3. It's going to be in between there. This is 3 here, but we needed minus 3, 1, 2, 3, 4, 5, somewhere there. So that will be our x2. y2, which is minus 3, 6. So it must be on top straight, but at what? At 6. That's minus 3, 6, and z, it was minus 5, 4. That was minus 5, 4. Our z2, minus 5, 4. So minus 5, 4, meaning to say you're considering at minus 5 there and 4. That's 1, 2, 3, 4, 5, somewhere there. That will be our z2. So these are the points that we need from this point to this point, this one to this one, and this one to this one. We have got our image, which is exactly the same as our object. Remember, a rotation, we are talking of the isometries where the object and the image, they are supposed to be the same. What you have on the object and what you have on the image is the same. That was the concept there. Then if you check on D, we are given this triangle x3, which is now given as minus 3, minus 3. Draw and label this triangle that you're given. So we're going to mark the points x3, y3, z3 in order for us to have this triangle. So that is the condition that you are given. You are given points. So the first point, minus 3, minus 3. When x is -3, y is also -3. So it's gonna be in between here, guys. That's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So let's say this is our x3. Then also we have y3 -12 -3. -12 -3. You consider x there. -12 and -3 is supposed to be in this line, but somewhere there down it, -12. Okay, let's open the same line there. 1, 2, 3, 4, 5. Okay, that will be our y3. Then we also have z3 -6 -9. Okay, -6 here and -9 in between a -8 and -9, -8 and -10, but under -6 down the -6 here. Okay, so it's gonna be 1, 2, 3, 4, 5, somewhere there. That was going to be our Z3, and we can join the the X3, Y3, Z3 triangle that you're given and describe the transformation that you're given, which is mapping the triangle of XYZ to this triangle XY, X3, Y3, Z3. By just looking into these two triangles, we think of enlargement. And the moment that you think of the enlargement, I said you must think of what? The two-way stretch at the same time. But by just measuring the sides, we're going to take your protractor, which is best is to measure using, you can take even a divider. You measure the side of the image, X3, Z3, you divide to this one, you measure it. You're going to see that this side was going to be divided into this side 3 times. The same thing, you do it on Y3, Z3 to YZ. You divide, it was going to be 3 times. The same thing on this side and this, it was going to be 3 times also of the X3, Y3, and XY. By having that you're having a same value 3, 3, 3, 3 when you divide, it means that's a straight enlargement. All you just need is join your corresponding points, x to x3, having this as a continuation x to x3. You just extend your points if you are not sure of where these points are going to meet, but you mark x to x3 or you join x to x3. You do the same thing from y to y3. You join the points and see what's gonna happen. You do the same for the z and the z3. This z here that you're seeing, you connect it to the z3. So all these points that you are joining, z to z3, this one to this one, they meet at a certain point. Where they meet, that is the center of the enlargement. Already by joining these points, you were knowing that it's an enlargement. By just joining these points, you are knowing that it's an enlargement. All right. So that's our aim. We're going to describe it is an enlargement. That is the major part, because they asked to describe fully. To describe fully what you are given there. So now you can describe it is an enlargement. That is our aim. So it is an enlargement. So remember, on the enlargement, you need the center of that enlargement, and the center of enlargement, we saw that's as 0, 0. So center 0, 0, and we need the scale vector, which you can measure the sides. You can work with the distance that you are measuring from the center to the image, center to the object. You can measure the distance of the side. But that measurement of the 333 that you're obtaining, that is our scale factor. But only that you have to figure out the center is in between of the object and the image. The center and the object and the image, they are separated by the center, the object that side, the image that side. On that condition, the scale factor will be a negative. So meaning to say, from the 3 that you are getting, you just write it as a -3 from that part that we are seeing. So that was going to be our scale factor for this enlargement that we are given. And from there, we need to write down the matrix which represents the transformation in E. Remember, enlargement, the matrix for enlargement, which is from the Cook, K00K that we talked about, where K is the scale factor, -3, 0, 0, -3. So this is the matrix where you are supposed to have the scale factor. Okay, you're supposed to have the scale factor there. Find the LCM on number 12 of this. Give the answer in index form. So in index form, the LCM, you simply consider all the terms, all the numbers that we are seeing. But if the numbers are common, like the 2, the 3, you consider where there is the highest power. In terms of 2, the highest power is on 5. In terms of 3, the highest power is on 3 to the power of 3. In terms of 5, the highest power is 5 to the power 2. In terms of 7, 7 to the power 3. Remember, LCM, you take everything that is presented that you see there. Everything. Every number is supposed to be there. But when common, take the one that appears the most. So the one that appears the most is the one with a bigger power, bigger exponent. Simplify. There we are supposed to just apply our BODMAS. This is a product that we are having here. So remember, BODMAS, like I said, it still exists. Still exists. Multiplication, addition. Okay, consider multiplication because we don't have this division. So multiplication, these two, there's a multiplication. These two, there's a multiplication. So let's multiply and see. 6u times 5u, that's 6 times 5, which is 30u. Minus 3 times 4u, that is 12u. Minus the 12u, which is already there. We no longer have multiplication, but just subtraction. We're just subtracting 30 minus 12. Then whatever that you're going to obtain from this 30 minus 12, which is something like 18, that's 18u minus 12u. 18 minus 12, which is 6u. Just like that. All right. Item 2, just convert this, multiply, add. So it's going to be 4 times 8, which is 32, plus 1, which is 33. So this will be 33 over 8 times 4 over 11. Remember your division. So it's going to be divided 2, multiply again, then add 18 plus 2, which is 20 over 3. Okay. With the multiplication, we can multiply, yes, which is fine, but let's just get rid of the division. 33 over 8 times 4 over 11 times, you invert the second fraction after the sign, after the multiplication. That is the one that you change. So it's 3 over 20. With this, we can reduce our numbers, guys. The 11 here, which is 3, 4 here, which is 1, the 4 here, which is 2. It's nothing that you can reduce, just left the relationship to multiply the numerator to the numerator. 3 times 3, which is 9, over 2 times 20, which is a 40. So it's going to be 9 over 40 as a fraction. If you're having this as a fraction, that is what you're going to have at the end. See item 1, during a 1-hour radio program, There are 12 minutes of talking. Remember, an hour is equivalent to 60 minutes. Why are we talking about minutes? Because we are related the rest in terms of the minutes. 12 minutes of talking. The rest was music. Out of the 60 minutes that we have, we used 12 for talking. What about the rest? So that is 60 minus 12. And if you subtract this 60 minus 12, we are obtaining a difference of 48 hours. Meaning to say music was going to carry 48 minutes in terms of the program. Calculate the percentage of the radio program. That was music out of the 60 minutes, which is the 1 hour of this program. 48 minutes is for music. So it's 48 over the time for the whole program, including the 12 minutes. 48 over 12 times 100%. So guys, like I said before, this is paper 2. This is enough. This presentation that you are seeing is enough for you to indicate or represent your answer. So your answer in this case was going to give you 80, which is 80%. So the music part took 80% of the radio program that we are given out of the 1 hour, which is the 60 minutes. It took 80%. Item 2, given that y is 2,9 times 10 to the power of 2. Evaluate the square root of y minus 1, giving your answer in standard form. So 2,9 times 10 to the power 2, you can have it in ordinary form. Remember, this is 100. Just 2,9 times 100, which is 290. Just move 2 commas to the right. So it means this square root that we are supposed to evaluate, it is the square root of 290 minus 1. That is y minus 1. Y is equal to 290. So 290 minus 1 is equal to 289. We can subtract these numbers and obtain a 17, which is an ordinary number to be converted to standard form. This number between 1 and 10, 1,7 times 10 to the power of what? Times 10 to the power of 1. That is now in standard form. These two numbers that we are seeing are supposed to be added, and the answer is needed in the base of 5. Both numbers are not in base of 5. So we can convert them to the base of 10 so that it's easier for us to work with. Remember, in the base of 10, 3 times 9 to the power of 1 plus 8 times 9 to the power of 0. 9 to the power of 1, that is 9 times 3, 27 plus 8. You have this number in base of 10. That is 35 in the base of what? Base of 10. Same thing with the 1001 base 4 to the base of 5. I mean to the base of 10. Power of 0 here, power of 1, power of 2, power of 3. So that's 1 times 4 to the power of 3. This part, you can just neglect it. Let's talk about this 0, 0, 0 there. So let's talk about the last part. 1 times 4 to the power of 0. 4 to the power of 3, which is 64, plus a 1, which is 65. So this is the number in the base of 10 also. This is a number in the base of 10. So let's add the number in base of 10 to the number of base of 10. It's easier for us to add these numbers. We are used to these guys. So when you add, it was gonna be 100. And this 100 is in the base of 10. But the answer is the major part in base 5. So this answer that we obtained is supposed to be converted to the base of 5. So that's it. Let's see. 5 into 100, that's 20. Remainder 0. 5 into 20, that's a 4. So it's going to be 4, remainder 0 here. 5 into this 4, that's going to be a 0. Then you put this as a remainder. Like I said, from the bottom going up, that is going to be your answer in the base of 5, the one that you're dividing with. So the answer was going to be 4, 0, 0. So that's 4, 0, 0 base 5. So these are the typical questions that we were given in our June examination paper 2. So I just hope with time, guys, we do work more introductions, because what we need is to understand the concept. You can revise 100 question papers, but if you do not understand the concept, they will change the same simple thing from one question paper to another, and you repeat making many mistakes from that. Understand the concept. You keep on learning new things from each question paper because of the concept that you do not want to work on as a separate thing. If you understand the concept of a topic, you are done. It's a repetition, but that repetition is backed with the understanding of the topic. So let's do as many questions as we can. Let's also invite others to the Math Zone African Motives family so that they can learn as much as they can, as just the same way as you are doing, preparing for the exams which are ahead of time. But for now, guys, that's it. Till we meet again.